If you want to become an AI engineer in 2026, this video will give you a very realistic picture of what you actually need to learn. The first one is core skills. You need strong Python programming. Second, you need system design. AI engineering is system engineering. You need to understand APIs, services, queues, failure, scaling, and how components interact under load. Now, let's talk about core AI concepts which matter more than tools. You're usually not training large language models from scratch, but you are customizing them, orchestrating them, and deploying them. So you need to understand how large language models work at conceptual level. You need to learn what does mixture of experts mean, what do sparse architectures optimize for, when does a smaller model outperform a larger one. You should also understand multimodal models. Next, you need to understand the model landscape. What are the state-of-the-art open source models? What are the state-of-the-art proprietary models? And just as important, how to interpret benchmarks. Benchmarks for reasoning, benchmarks for coding, benchmarks for retrieval and multimodal tasks. Benchmarks are mostly imperfect, but they guide you with the real trade-offs. Now, let's move to large language model application concepts. You need to understand things like tool calling, structured outputs, prompt engineering, and context engineering. You should understand how short-term memory works through context windows and how long-term memory is implemented using embeddings and external stores. You should understand how embedding models work, how similarity search works, and how vector databases are used in RAG systems. Then comes agentic AI systems. You need to understand how to design single agent systems, multi-agent systems, and common orchestration patterns. Now, let's talk about the genAI tool stack. You don't need to learn everything, but you should know at least one or two tools per category. At baseline, you should be familiar with things like LangChain, LangGraph, and LangCement. You should also know how to use Llama Index and OLama. For embeddings and retrieval, you should understand vector stores like Pinecone or VVirt. Now, talking about production realities, which is where AI engineers are made or broken, you need to understand trade-offs between latency, cost, quality, and reliability. You should be comfortable with concepts like caching, batching, streaming outputs, async execution, and rate limits. You also need to understand deployment and inferencing. Next is fine-tuning concepts. You need to understand the difference between full fine-tuning and parameter-efficient fine-tuning like LoRa and QLoRa. You should know when fine-tuning makes sense versus when prompt or context engineering is enough. You also need conceptual understanding of supervised fine-tuning, reinforcement fine-tuning, LLM as judges, human in the loop, and RLHF. Finally, two areas people often miss. First is evaluation and observability. How do you test an LLM system? How do you detect regressions? How do you measure quality over time? And second is security and safety basics like prompt injection, data leakage, access control, model misuse, etc. An AI engineer in 2026 is not just somebody who calls a model API. You are a system engineer for intelligent system. You need to understand everything from models, data, retrieval, agents, evaluation, and production trade-offs.